everybody. So this section of today is going to be a little hands-on. Hopefully, you're going to get a little active and thinking. So what we're going to do for the next little bit, we do have a session. We're going to bring Kim back up in just a minute. What I'm going to do real quick is show you guys access to the training environment that we're going to use for today. So you should have all received an email with some credentials to access this environment. We're going to give you access to a GPU-powered environment to actually check out a lot of our enterprise products and LLMs. And so I'm going to just demo that in just a second on how to access that. So, if you're in for that, get out your computer, and we're going to navigate over there. And then what we're going to do is basically have like a few back-to-back sessions where we have a little bit of theory, then we're going to practice it, theory, and practice it, that sort of thing. So I'm going to go ahead and start sharing my screen. Yep, so just a little bit of an introduction. So we're going to focus on, responsible AI and really specifically model risk management as it's seen in GenAI here. But I just wanted to give a little of a shout out. We did do a full-blown GenAI training just a few months ago we put together, and that is accessible to you. So there's the GitHub link there. And I will share these slides with you in just a second, but bear with me. The GitHub link is there, and that includes pretty much everything end-to-end, not just model risk management or responsible AI, the full thing, right? So that's available to you in the training environment as well. You'll actually be able to check out all that material that's there too. So just as a heads up, this is kind of the agenda that we're going to go through just for this period. The durations might change. Our schedule today is a little condensed, so we might kind of condense things right before lunch. But so I'm just going to kick it off real quick, and I'll stop talking in just a second. We're going to bring Kim back up to talk about large language model interpretability. Then we're going to take a deeper dive into that chain of verification tool that Megan was just talking about. We're going to have Srini, one of our developers of our Eval Studio, come up and talk about why we built this Eval Studio. Then we're going to actually use Eval Studio. So everyone here is going to be able to run their own leaderboards and evaluations for generative AI applications. Then we're going to check out hacking, so like guardrails and prompting. And finally, I'm going to show just kind of an end-to-end example using the complaint summarizer that Agus demoed, but everyone's going to have access to it, right? So, yeah. Yeah, if you need credentials and don't already have them, raise your hand and H2O person will come assist you. All right, so while that's happening, check this out. So this is the URL to access the environment. It's just genai-training.h2o.ai. So if you've got a computer, open up your favorite browser and go over to genai-training.h2o.ai. Like I said, you should already have your credentials. If you don't, folks are walking around to give them to you. And the other thing is we will be providing access to this for about a few days, 3 days after the conference. If you want to explore doing a POC, we can actually deploy this on-prem. So everything that we're looking at today can really be deployed on-prem if you actually have a use case that you want to test this out on, just as a call out there. And so with that, Kim, I'm just going to turn it right over to you if that's okay with you. And away we go.
Thanks. So I'm going to start things off by talking a little bit about interpretation for large language models. So generally with traditional models, we're dealing with training data, maybe credit card data where we have certain features about a customer, maybe past payment history, credit rating, etc. And we also have labels for something that we're trying to predict, maybe whether the customer is going to default within a certain period of time. So we feed those into one of the traditional AI models. Could be a neural network, it could be a tree-based model. And we train a model in order to predict what a similar customer in the future, in the case of a credit model, it would be maybe their chance of defaulting. With GenAI, things are a little bit more complicated because we're dealing with unstructured data, both as the input and the output. So we could be dealing with something like a combination of language and images as the input to the model. then the model's generating novel content on the as output as well. So we're dealing with possibly language or images that we need to interpret. And also we don't have labels for the data set, so we don't necessarily even know whether the model is whether the model's coming up with a reasonable answer or whether it's hallucinating, which sometimes happens with LLMs. Yeah, so our main complications here, in addition to the fact that the GenAI models tend to be quite a bit bigger with billions or trillions of parameters, are that we have this unstructured input, and we want our model to be able to perform similarly under similar conditions, but there are certainly different ways that you can possibly phrase the same question to the model, different ways to instruct the model as far as how it should answer a question, what its demeanor should be. And you also have a choice of possibly giving the model examples of the task that you want it to perform. And all of those can affect whether the model, how the model is going to perform the task that you want. And in general, you need to have some testing suite in order to make sure that the model isn't too easy to break by possibly changing the prompt phrasing, that you're getting similar solutions under different situations. Yeah, and the other problem is that we also have unstructured output. So there are just many, many more ways that you can test different qualities for the unstructured output. And in addition to that, there are more ways that things can go wrong. And in order to generally test how different models are doing, it's a good idea to think about what different things can go wrong and maybe have a set of benchmarks to test how well your model's doing in different areas. And one example of that is Trust LLM. It was a recent paper that was posted on arXiv a week or so ago. And the dimensions of the responsible AI output that they looked at were truthfulness and accuracy. So first of all, is the model producing accurate responses to your questions, or is it imagining things? So they have some tests for that. Safety, you want to make sure that the model will be respectful, or it's not doing something harmful like telling someone that they should make recipes involving gasoline and sample them or something. Fairness, you want a model that's free of stereotypes about different groups. Robustness, you need your model to perform well under different reasonable operational situations. Privacy, it can't leak personal information. And ethics, which came up on the panel, you want the model to have some basic understanding of right and wrong, and that it shouldn't be giving irresponsible outputs. Yeah, so these benchmarks tend to fall into two different categories. Either they're giving the model two different choices and trying to see if it can identify which ones are problematic, or sometimes the benchmarks involve giving the system a prompt that you think will cause problematic behavior, maybe asking it leading questions to see if it causes the model to produce false content, or jailbreaking, or trying to provoke toxicity. And people will talk more about jailbreaking later. Yeah, and this shows the results they came up with. It was the Trust LLM study was a fairly large study. They tested 16 different models in the 6 areas they identified. And they noted that generally, the first 4 models were closed source models, and the next 12 were open source models. And generally, they were getting better results from the closed source models and from the middle part that's kind of darker is Llama 2. So they were getting the best results from the llama models, as well as some of the open source models like ChatGPT and GPT-4. So definitely if you want to use an LLM in production, you want to have some set of tests that you can run to understand how well the model is performing in terms of different possible problematic responses. Yeah, and their main conclusions from testing these models across 30 data sets was that generally trustworthiness and utility were positively correlated. So the models that had a general better understanding of language were also better at doing complicated tasks like understanding whether there's a stereotype involved or understanding ethical situations, which makes some sense. Though they did also find that models that were over-aligned for trustworthiness were possibly more difficult to use because they were maybe over-identifying problematic situations and refusing to respond to reasonable requests. Yeah, so in general, if you're just trying to understand how well a model performs in different categories and overall global performance of an LLM model, it's good to have some benchmarks set up. But we're also concerned with how well we're also concerned with testing more local situations. How well is an individual response? Performing well in terms of the 6 different categories that they identified? So I wanted to talk a little bit about how you might test individual responses for accuracy. Because certainly if you have an LLM deployed, you want to have some check as to whether it's hallucinating or whether it's giving you a reasonable response to your question. So accuracy is a much simpler problem in terms of supervised machine learning because we have labels for the data. So in traditional machine learning, to determine accuracy, it's just a math problem. We can compare what the model's predicting in a confusion matrix, that's a confusion matrix from driverless, to the actual labels and just calculate how accurate the model is. Once we switch to LLMs, again for LLMs we have unstructured output. In the case of LLMs, usually just language. So it's more difficult to even just understand whether the model is giving you an accurate solution or not. And probably the simplest, most logical way to test for accuracy is to try to ground the model in some external source. So we want to check whether the response it's giving you corresponds well to some external check on the accuracy of the model. And in an ideal world, you'd want to have the model tell you, well, based on the training data, I've learned this and this and this, and this is how I'm formulating the question. But for large language models, the training data tends to be hundreds of gigabytes, so a direct comparison to the training data is a bit cumbersome. So there are other choices of data sets we might compare the data to. In the case of RAG, which came up in the earlier sessions, in the case of RAG, you have a certain set of documents that you'd like to compare the answer to. And that makes checking for accuracy a little bit simpler than if you just have a free-form response, because you've given the model documents that you want it to use to formulate a response, and you know which sections of the documents were given to the LLM as context. So if you happen to have a source of documents that you want the LLM to use, that somewhat simplifies the problem of checking accuracy. There have also been papers that try to check the effect of tuning data. If you've taken a model and tuned it on another data set, you might want to know how the tuning data affects the output of the model. You might check against an external source. You might use chain of verification in order to figure out what different aspects, in order to break down the question into different categories and have it individually check things. And Navdeep will talk about chain of verification later. Yeah, and if you're training a smaller LLM, you could use a larger LLM as a fact check. And in the case where you don't have anything to compare your result to, there are some methods such as self-check GPT that run different statistical samples from a model and just check whether the different samples are consistent, assuming that with the assumption that hallucinations will occur less consistently than accurate information. Yeah, so as I mentioned, RAG, or retrieval augmented generation, is a fairly straightforward solution if you want to check the accuracy of a response. And in RAG, you have a certain set of documents that maybe it's annual reports or something that you want the model to take a response just from those documents. And the general process of establishing a RAG system is that you want to divide the documents up into different chunks where different pieces of information could occur. The chunks are translated into an embedding, and then when someone asks a question, the query or something related to the query is also translated into an embedding. And then you're looking for embeddings similar to the query, and asking the model to combine the information from the relevant parts of the documents that were retrieved as similar embeddings. So the nice thing about RAG, this shows a screen grab from the H2O GPT-E, is once you've asked a question, the RAG finds relevant parts of the document and feeds it to the LLM to formulate the question from just those parts of the document. So you have a pretty good idea of where the LLM is finding its information. And one of our newer products, the Eval Studio, also has metrics for understanding how well your RAG is working. So it looks at the various aspects of RAG: context precision, context recall, whether the information that you're retrieving from the documents is relevant to your question. It looks at whether the LLM is staying faithful to the context, and it has a score for answer relevancy, how well the answer relates to the extent to which the answer relates to the question, all of which get combined into a RAGIS score. So you can use Eval Studio in order to check how well your RAG's working, and if it isn't working, you may need to tweak some things such as the chunk size, how you're dividing up the document, or whether you're adding metadata to your search. Yeah, another method that someone could use in order to try to look at the effect of training data on a response is influence functions. Again, they don't quite scale to large training sets, but influence functions have been used for decades in statistics, and there have been a number of papers coming out analyzing different influence functions. DataInf was a package for analyzing the effect of the fine-tuning data and how data in your fine-tuning data set is affecting the response of a model. There have been a couple of data models track papers that they trained a model on a large set of photos many different times using different subsets of the data. And then the kind of cute thing about the data model method is for each data point within the data set, they were just using a binary indicator of whether the data point was included or discluded from that individual training set. And then they trained a simple linear model on these individual indicator functions, such that the coefficient of the linear model indicates the extent to which a photo in the training data set affected an individual score in the test set. So we can see in the training data set in the first row, they were trying to identify, something gets identified as a plane, and you can look at which of the training set samples most influence the classification plane, and the ones that most negatively indicated that, well, maybe it's not a plane. So you can see that the most positive ones are all kind of similar looking planes, and the most negative ones were things with a similar color scheme that are maybe angular and look like something that could be a plane. So it's kind of interesting because it's a method to look at how the training data is affecting the model decision. And people have been working on similar things. There have been a number of papers involving large language models where they're trying to use influence functions to look up where in the training data an answer is coming from. This answer was a nonsense answer where they were testing jailbreaking, and it says something about Nickelback being the official band of Canada. And the influence function tells you where it's getting references to Nickelback, though obviously it doesn't have the false information in it. And as of now, the influence functions don't scale to something you could use on a full training set for an LLM, obviously, but I think it's an interesting method from statistics. Yeah, and I already talked about self-check GPT a bit. So in the case where you have nothing to compare a result from an LLM to, the self-check GPT method is to sample different responses from the LLM, and then you can use the different samples as something to compare results to. Generally, you'd expect that if it's hallucinating, that will come up fewer times in different statistical samples. So they use different samples from the same LLM in order to test whether a model might be hallucinating. Yeah, and one more method that's useful in both supervised learning and in LLMs is, again, something that came up in the panel, adversarial testing. So in traditional LLMs, or in traditional supervised learning, we want to be able to test how much you can change different features in order to get a change in the model outcome. Just to get an idea of how robust an outcome is, whether some result, that if it's credit card default, how close is the person to changing their outcome. And counterfactual analysis can give people an idea of what they would change if they wanted to change, say, a credit card approval. Yeah, and we do have a tool called Model Analyzer for supervised data, which allows you to analyze individual results from a model, and what the easiest way would be to change the result from the model. So for instance, this is from the Income 50 data set. If you look up the second row in the model, it's someone predicted to be making less than 50,000, and the adversarial detector tells you which features you would change if you wanted to be categorized as someone likely to be making more money. So in this case, it's saying if you increase the education and change your occupation from blue collar to white collar, then that would improve your chances of being higher income. And in terms of LLMs, this also came up during the panel. We also want to have some kind of adversarial testing to see how far we can change an unstructured input in order to change the output, in order to substantially change the output of a model. The tricky thing, though, is that there are a lot more things that we can change. So there's prompt design, changes in instructions to the model, how you want the model to behave, whether you're giving the model examples or not, whether you're using chain of thought to try, or some other similar method to try to guide the reasoning of the model. You can look at differences in context, or what kind of, or how you're retrieving information using RAG, and any number of other tests. And generally, you want a model in production to behave similarly under similar conditions. You don't want small changes in prompt phrasing to change the output of the model. Yeah, and one more thing. If you do find, using a benchmark or something, that your model isn't performing as well as you might like, this is still partially an art, more art than science, but there are a number of things you could try in order to improve the performance of your model. Certainly modifying the prompt or instruction to the LLM could be used in order to improve performance. You might just tell it, hey, watch out for certain. Okay, so you could just tell it to watch out for certain problematic behavior, and sometimes that can improve performance. You could choose a different base model. We saw that there's quite a bit of variance between different models. So if you're getting poor performance, in a certain category, you could choose a different base model that has been shown to work better in that category. You could try fine-tuning the model. Maybe if there are biases, you could feed it a data set with more evenly distributed pronouns that might improve the model's response to bias, the model's bias response. Yeah, you could look at altering the document retrieval process in order to get more accurate responses. And obviously, you can just monitor the output of the model to try to understand whether it's giving a problematic response, and you could block responses that are featuring stereotypes or possibly giving incorrect answers. Yeah, so definitely interpretation of LLMs is still an evolving field, and I'm sure there will be many breakthroughs in the future, but I've given you some idea of what methods you might use to interpret a large language model. And I think I will pass things on to Navdeep at this point.
You got another one I can use real quick? Cool. Thank you. Thank you, Kim. Yeah, real quick before we bring Navdeep up, I had an oversight. Yes, please. A round of applause. I had an oversight. I was going to show really quickly how to access this environment, but I had the H2O folks kind of show some of this. So yeah, on my laptop here, let me just demo this real quick. So I'm going to go to GenAI. Man, it's really hard to type with one hand. So if you go here, you should be able to see the apps that we're going to look through right now. You should see some stuff at the top that we're definitely going to look through. Enterprise HOGPT. I think Arno demoed some of that. Some others demoed some of that this morning. We're also going to check out Eval Studio. So if you do have access to the environment, feel free to poke around, although we are going to be doing a little bit of a guided flow for the rest. Also, probably really important that I forgot to show, this one is the slides. So if you want to follow along with the slides, even fast forward, check out some of the content. There is an app in the App Store called GenAI Training Information. And if you just click on that, and then click on Visit in the top right, and it should go right to the slides that we're kind of walking through here. So, you have a problem? You don't see this app, is that what you're saying? Are you in? Yeah, Srini, can you just help her? Thanks. Yeah. Okay, Navdeep, come on up, and we're going to take a look at chain of verification with Navdeep and an application that he built. Cool, yeah. And then just go into slideshow mode. We should off to the races. I'm here to help.
All right, perfect. Yeah, so today I'll be talking about a method known as chain of verification for explainable AI. So essentially what chain of verification is trying to do is just improve the accuracy of LLM by avoiding hallucinations. So what it does is it systematically verifies its result with itself, basically. It's kind of debugging itself. The method itself is just 4 stages. So the first stage is getting a baseline response. So that's essentially just asking the LLM a question and recording that response. The next step is the verification question generation. So essentially that is based off the baseline response, now ask the LLM to create some verification questions for that response. Once that's done, you execute those verifications. And once those are executed, based off of those answers, you can generate a final refined answer, or you're hoping it's a refined answer. So now I'll go over how the verification questions are classified. So the first category, these questions can be classified as is a wiki category list. So basically this is if someone's asking for a list in terms of an answer. So the example here are who are some politicians born in Boston. So you know that the answer itself will be a list and the baseline prompt will be categorized as such. The next one is a multi-span QA. So this has to do with seeking independent answers. So one question you'll probably see as an example is, who invented the first mechanized printing press and in what year? So that's an example of a multi-span QA. So once again, the baseline response will get categorized as this, and then it'll use this chain to generate more verification questions and generate more answers. And the last one, or the last category, is just long-form generation. So this is some type of open-ended question, things like that. It'll get generated like this, and then that chain will be triggered. So here's an example of chain of verification. So the query itself is name some politicians who were born in New York, New York. There is a baseline response we can see here. So it picked politicians like Hillary Clinton, Donald Trump, Michael Bloomberg. Based off of that, you can see it's a list. So it'll get classified like the Wikidata list I showed earlier. So now the verifications for this are questions like, where was Hillary Clinton born? Where was Donald Trump born? Where was Michael Bloomberg born? So these are just verifying the response itself with its own set of questions. And then based off of that, you see the answers there. So you can see, Hillary Clinton was not born in New York, New York, but the baseline response said she was. You can see Donald Trump was, so the baseline response got it right. And then Michael Bloomberg was born in Boston. So 2 out of the 3 answers that this LLM gave were incorrect. And you can see that now through the execute verification process. Based off of that, you can get a final verified response. Now the verified response can be just a correction of the original prompt and just gives you a subset of the answer. So in this case, if it's a list and 2 out of 3 are wrong, it might just give you 1 subset. So just Donald Trump in this case. But you could see also it gives another politician as well, AOC. So the baseline or the final response can also add on to the original answer. So not only to fix the baseline response, but also improve it by giving more information. So those are the few things that chain of verification can do, and this is just one example. Now we'll talk about how it's related to explainable AI. So these are just 4 sort of subtopics I broke apart for how it's related to explainable AI. So the first part is, interpretability and transparency. So the verification process itself is a good way to fact check the baseline responses. And then by doing that, you just improve transparency. You're sort of giving this LLM, or this LLM is doing some self-reflection and trying to figure out, what it's really, or what the real thought process is. And by doing this, you increase reliability and trust with the LLM. You might also uncover bias and fairness issues through this method, through chain of verification. And then also user interaction can get improved as well, given, you're giving better answers and things of that sort. So now, we can try out the application itself. If you guys want to navigate to chain of verification, it should be in the App Store. Let me see if I can do. So here, yeah, we can try to run the default if you guys want to try that one. And if you guys have access to the slides, you guys could always cycle through. There's just a few example prompts in subsequent slides, so you guys can cycle through and run other questions as well. Oh yeah, so right now it's the same process that we talked about before. So there's an initial response that you're seeing there, and then based off of that, it will generate some baseline questions. The generation of the baseline questions will fall into 3 different chaining methods, and that's based off of the baseline, that's based off the original query itself. Are you looking for a list, or is it a long generation, things like that. Once that's done, those verification questions will be answered by the backend. And then based off of those answers, a refined answer can be given to the user. Now, I should mention that it won't always be refined. There might be situations where the original response is just fine, so the refined answer will agree with that original response. There might be situations where it returns a subset because 2 out of the 3 are wrong, something like that. Or it can just add on to the answer and give you more information that the original response did not contain. Okay. Yeah. Yeah.
Yeah, so what Navdeep's app is doing right now, for what it's worth, is it's all of us are doing this at the same time. So we're all hitting an LLM right now and asking it to do a bunch of things. So if it's a little slow, you're going to see that. But like I said, you're going to have access to this environment for a little while. So even if it's a little slow right now, definitely try it either later today or even tomorrow, and see if it works a little bit faster. It should finish one of these queries though. But the whole point of the app is to really explore what is chain of verification. With any prompt that you want. Yeah. Yeah, that's a good question. So how many folks are actually following along as we go through? How many people have actually been able to access the chain of verification app in the environment? Okay, good. That's a fair number of people. Okay. Has anyone's actual chat completion completed yet? No? Okay. We broke it. Yeah, go ahead.
So this method, does it work with questions of how and why type, or only of when, what, who? No, it's just there's no limit on the query. You're dealing with the LLM, so you're asking the LLM questions, and it's giving you responses. There is no limitation as to what type of question you need to give. So you can imagine. Verify the more complex questions. it'll do it's verifying itself. So it's with itself, it's you're relying on the LLM to kind of verify itself. So you're asking the LLM like, here's a baseline response. Okay, now generate some verification for this, and it'll generate a bunch of questions it's going to try to answer. Um, so that's essentially what it's doing. And of course, the model that we're using here is a very simple model. It's like 7B or something like that. You could imagine if you were to deploy something really heavy duty, the responses can be a little bit more complex, a little bit more long, especially if you increase the number of tokens that can be returned, it can get a very long answer. And like I mentioned before, the answer can become longer from the refined response because it might give you more information that's more useful. Yeah, yeah. So so I'll just go over some of the benefits and limitations of this method. So, you could try to enhance, it will try to enhance reliability of the answers given by the LLM. It could increase the depth of understanding. So like I mentioned before, by giving you better answers or longer answers, it increases the depth of understanding itself. There's also some educational value given with this. Now, the limitations are it can't always remove hallucinations. It's that's just something it can't do. It's not perfect, so it won't always remove hallucinations. Um, it's also sort of limited in the mitigation of hallucinations to a certain degree. So it can't. It'll try its best to limit certain hallucinations, but it is limited somewhat. It could take a long time depending upon the query you've given it. So the more complex the query, the more work that has to be done in the back end. And of course, there's an upper bound on improvement. So there's a cap as to how much you can improve. You'll hit a point where it just can't get better anymore. So that's one of the limitations. Now, how to improve it overall? Prompt engineering is always a good way to improve it. External tools. Specifically, if you have a custom use case and you're using a RAG, it should do better as well. Having more chains, like we mentioned before, like long chain, all those type of things, that will help, and also human in the loop. And then in conclusion, I just want to say, this is aiming to, increase model transparency, reliability, and trust, but it's not a silver bullet. You need a lot of different type of testing to really understand what your LLM is doing. And, that will be spoken about right after this, I think, with Eval Studio. And that's all I have to say about chain of verification.